Hello everyone. I will present on the data format and standards that we use in OBIS, the Ocean Biodiversity Information System. So my name is Appeltans and I'm the project manager of OBIS. At the moment we have 61 million occurrence records in OBIS from 133,000 species, and we integrate data from 3,260 data sets. In the past, OBIS mostly dealt with occurrence records. We also have abundances and biomass, but scientists, they don't just measure an occurrence record or an abundance or biomass, they also take biotic measurements, sediment samples, they measure the water column, nutrients. More and more we see more data coming from tagged animals, but you also have plankton nets, the VPR, the video plankton recorders. Scientists take subsamples and slices. Sometimes they have data from transects or quadrats. And the amount of data that scientists could share with OBIS was often very limited. And it was not always easy to convince the scientists to share just a subset of the data, because they wanted to share all of their data with their colleagues through OBIS. And also, when the Global Ocean Observing System, or GOOS, and MBON, the Marine Biodiversity Observation Network of GeoBON, when they were developing the essential ocean variables, or the essential biodiversity variables for the ocean, they needed to have a data infrastructure to share the EOV and the EBV data. And we had made this agreement, they made this agreement with OBIS to support them in this. So we had to look into expanding our capabilities of the Darwin core structure that we were dealing with. And we were looking, and this was already in 2017, we had a workshop which was co-funded by EMODNet, the European Marine Observation and Data Network. We were looking into the measurement effect extension to capture all the additional measurements. But the problem of the Darwin core archive is that it only worked with the star schema. So you have your core file, and you can have multiple extensions, but you cannot link an extension to another extension. Every extension is just linked to the core. But we wanted to have biotic measurements and abiotic measurements both linked to the sample, and the biotic measurements linked to the occurrences. So we had to find a way around. And so that's when we proposed the extended measurement effect extension. So basically we kind of hacked the star schema, and we added occurrence ID to the measurement effect extension. So this allowed you to also link an occurrence, the occurrence with the measurements, or the measurements with the occurrences, at the same time linking them with the event core. So in the event core, you have all the information on your sample, time, location, depth, event hierarchy, samples, subsamples, slices, as I mentioned before. All the taxonomy, identification, occurrence details are in the occurrence extension. And then you can have all kinds of sampling facts and measurements into your measurement effect extension, like equipment, sampling methods, length, duration, volume, abiotic measurements, and biotic measurements. All this is described in our paper in Biodiversity Data Journal, with the link below. And in that paper, we developed a number of example cases where you have how you should combine your biological measurements with, for example, CDD measurements, your video plankton recorder, or your tagged animals. And in the colored graph, you see how this can look like. So your sampling facts, which are in green, are linked to your sample. Your abiotic measurements, which are in yellow, are linked to your sample. And all your biological measurements are linked in orange here, are linked to your occurrences in blue. So we added occurrence ID to the measurement effect extension, but we added 3 other terms, which are ID terms. So you have the measurement type ID, the value ID, and the unit ID. And this is making OBIS interoperable. I mean, all the data sets that are shared in OBIS can become interoperable because we link them to the persistent identifiers in the NERC vocabulary of the British Oceanographic Data Centre, or BODC. So in the past, all that kind of information was just dumped into the dynamic properties term of Darwin Core, and now everything is structured, nicely structured, and that makes a huge difference. So this is all work in progress, and we are organizing together with GOES the number of workshops where we bring the community together and discuss this OBIS-ENV-DATA form and the standard, and propose something so that all the networks would share the data in a standard and consistent way. So, for example, for the macroalgae, sometimes you have quadrats, sometimes you have line transects. So here we developed this example where how this should be structured in the event core, the occurrence extension, and then the extended measurement effect extension, with links to the ID terms in the BODC vocabulary. So for example, measurement types can be shore height, surface area, cover, length, functional groups. The challenges with the habitat EOVs or EBVs is that the people need to agree on an habitat vocabulary. So to give you an idea of how far we are, what the status is in OBIS with this new data formats that we launched in 2017. So of the 3,260 data sets that we currently have, 398 use event core, 342 have event core plus the extended measurement effect extension, and 240 of those also have vocab identifiers. Of course, you can also combine the measurement effect extension with the occurrence core, and for that we have 650 data sets, and of 443 of those have vocab IDs. I also added information about the number of data sets that use footprint WKT. It's because there's still often a misunderstanding that OBIS is just point locations, and that's probably because we only show points on our mapper. But if you look into more detail, those points often represent the midpoint of a line transect or a polygon. So about a third of our data sets actually are not just point locations, but are line transects or polygons. So we have 55 million records that have measurements or sampling facts, and we have nearly 14 million records that use footprint WKT. So the extension is available through the GBIF IPT. It's no longer in the sandbox, so it's available to anyone that wants to publish data through the IPT, either to OBIS or GBIF. And I will now give the floor to Pieter Provoost, our data manager, for a few minutes to show you the strength of working with the measurement effect extension in OBIS.
Okay, so in this second script, I'm going to focus on the measurement effects data. And first, I'm going to fetch all polychaete occurrences from the southern North Sea. Okay, so now I have 172 occurrence records. And again, I'm going to extract the measurements. And in this case, I'm only going to keep measurements that have abundance in the measurement type. Note that in the script I am using measurement type and measurement unit, not measurement type ID and unit ID. And that's because these are not populated yet in all OBIS data sets, but that's something we're working on. And if we now take a look at the dataset IDs in our measurements, we can see that we have measurements from 20 different datasets in our table. Let's take a look at the measurement types and units. So these are all abundance. And as you can see, they're using many different units. And just to keep things simple, I'm going to apply another filter and only keep abundance measurements in units of individuals per square meter. So let's take a look at the dataset IDs again. So I have data left from 9 different datasets. And let's put these on a map. So this is my area of interest, and these are the 9 different datasets that have abundance data for my area. Now let's take a look at which species are best represented in our dataset. So we have Lanice conchyliga, we have Nephthys hamburgi. So I'm going to extract all the occurrences of Nephthys hamburgi and put them on a map. Okay, so now I have all my records for this one species, and I gave it a nice color and size scale to visualize the abundances. And I've also added a pop-up here just to show the abundance measurement and the catalog number. And finally, I just want to mention that it's really easy to publish your R code as a web application. So here I'm visualizing a Swedish benthic dataset. So I have some filters on the left. So I have species here, variable and year, and then on the right for that year I'm showing the measurement values on a map, and I also have a graph with the variable over time for each of these cells. So I can pick another species here. And I can also take a look at the other variables. Thank you for listening, and please get in touch if you have any questions. I'll make all the code that I've used in this talk available on GitHub at this URL.